All right, what's up, guys? Um, I kind of have been deceased for the past month or two. Just getting schoolwork done, or and also just being busy in general, you know. But I am back, and hopefully I do well because I've been so busy with schoolwork lately that I literally dropped back to blue. So I'm expert right now, which is something I really hope can change today. But yeah, if you're competing, good luck, because I wanna do well. A, and or B. Um, is it not just checking to see if like, okay, it's either, okay, it's yes or no. So it's literally just okay, string res is equal to yes, and size is equal to 1, card tag is equal to array of 0. Okay, so if the tag is equal to array I, size increases by 1, then res becomes no, size becomes 1, tag becomes array at I. If size is equal to 1, res is no. Remember, you're given endpoints and integer coordinates on a coordinate x-axis. The coordinate ith point is this. And do following no more than once. Take this point and move it by 1 to the left or to the right. Wait, so that if you can... Your task is determine if you can move some points described in any other way such that the new set of points form a consecutive segment of integers that have distinct coordinates. Oh, okay. Can't we just like try every possibility for the very first point? There's only 3 of them. Is this yes or no? Yeah. Delta less than equal to 1, delta plus plus. And value is equal to array at 0 plus delta. So in other words, if the absolute value of the value minus the current array is greater than or equal to 2, then we continue outer, because then it's not possible. Otherwise, the value just increases by 1. And then it's always possible. Okay. I want to run samples on this. And that's why I run samples on it. 2, then 3. So it becomes 2. Oh, yeah. Oh, I think we want to add it first. Yeah. Yeah. Problem B, Java 8. Right. Turbulent something. Oh, turbulent times are coming, so we decided to buy sugar in advance. There are N shops around this sugar. I shop sells 1 pack sugar for this many coins, but only 1 pack to 1 customer each day. Wait, I thought sells 1 pack of sugar for this many. We know that if you don't spend some amount of coins during a day, you can't use these coins during the next days. Okay. I'll be able to buy a single pack. How many packs will we be able to buy until that moment in total? The initial cost of one pack in each shop. Do we always use greedy? Like greedy for the cheapest pack? Yeah. Because, yeah. Because if we take like something that's not the smallest, then we can take smalls and have strictly more coins left. Okay. So it's like +1, +2, and so on. Maybe for each. Because, okay. During the first day, it causes AI. Second day is this. Maybe we can binaries. For each thing, we can binary search for what is the latest day in which we still buy this pack. Yeah. Okay. I think we can just binary search for that. Oh, I know binary search now. I'm so proud of myself. I didn't know that last educational round because I couldn't solve the binary search problem last time. I'm improving so much. Oh my goodness. Okay, whatever. I hate myself. Prefix of 0 is equal to rate of 0. Wait, so what is the question again? The total number of packs you'll be able to buy until prices exceed everyday budget. Okay, so we got 4 and I is equal to 0, or I guess the final answer will be yes, like for each sugar pack, how many days we go till we buy it. It's not sorted. Shit, it is not sorted. I need to sort this. I do need to sort this already. It's kind of important. Okay. And then for each day, we want to figure out. I want a binary search for how many days we can have long low is equal to 0 L days, just because that's the maximum number of days, and then long high. What is like a number that we can do that's like that won't like overflow? Okay, well, like for each possible day. Because the sum itself could be at most 10 to the 14. Okay. So while low is not equal to high, long mid is equal to low plus high. Long prefix. Okay, so we need to calculate. Like, so long cost is, so if this is the, okay, so this is like the first day, for example, that we want to try to buy this thing. So long cost is equal to array at A plus mid minus 1. Because we want to buy it in one on the very first, we want to buy it once, and that's the price on the first day. Long used is equal to 0L. If A is greater than 0, then used becomes prefix at A minus 1. And then used is must equal to, like, I guess, A long A times however many days have passed. Yeah, because like, if for example, this is like second day we're trying to buy it, the cost of this is original plus 1, take all the prefix and add 1 to every prefix. Yeah, well, to every element in this prefix. So if x minus used is strictly greater If it's greater than or equal to the cost, then we can buy this thing on this day. Y is equal to min minus 1, we do plus 1 over here, and then all we need to determine is to figure out what this upper bound is. Okay, used itself can be 10 to the power 14 plus okay, so this a itself can be like up to 10 to the power 5 if mid is up to 10 to the power of 9. Okay, I think it's fine. So 11, 0, 1. And however much that is. Okay, we got C. We're already doing better than last time. Wow. Given a sequence of integers, we're also given x integers 1 through x. He has to insert each of the extra integers into the sequence. Each integer can be inserted at the beginning sequence and or between any elements in the sequence. What is the smallest possible score of this new sequence, where the score is the sum of the absolute differences of adjacent elements in it? If there's an adjacent element before, okay, well, if we just put this progression at the very beginning or at the very end, then like that's how we can like bound this cost by a certain amount. Will the progression always stick together? Well, not necessarily, but because the thing is that if we consider like the smallest and the largest possible value, that's like a lower bound on our sequence, or like a score of the sequence. So is there a way that we can essentially insert values so that we never increase this, unless if it's the current maximum value or the current minimum value? Because the sequence is not initially sorted. Okay, sum of n over all test cases does not exceed this. Number of extra integers. But x potentially might be bigger than it, right? I feel like that might be the case. So the thing is that we can insert elements into the sequence, but we can't necessarily calculate number of permutations with exactly as many inversions and exactly x indices such that this is this. That's the whole problem. Number of p is size n. Oh, n is pretty large. Okay. Given a sequence of integers, this smallest sum of absolute values. Okay, so we always want to like fit. I think that's always like a valid move to make. Yeah. Okay, if n contained all integers of x, does that mean we can... Yeah, that means the answer never increases. If some integer of x is in here, then that means if it can fit in between some values, let me just put it in there. If it can't fit in between these values, then that implies that if x is bigger than this number, it's also bigger than this number. But if x is, and then we try like this to x, but if x is smaller than this number, oh, it's also possible that it goes down. Is it ever possible for x to not fit anywhere if... It's obvious that x can't fit if it's smaller than the min or larger than the max. Is that the only condition in which we can't fit numbers in? If it's like here to here to here to here to here, all the way up to here. Is there always a place where we could fit these numbers into here? Of course, that's going to be less than, and it's in like the minimum. So like at some point, the minimum from here to here, it'll always exist, like a point where it goes up. So it's like, it's kind of like IVT. Yeah, so I think that's always, so can't fit a value if and only if it's smaller than or larger than this. So how do we handle those types of values? What if we have multiple values like that? Do we always want to keep these values together? I think we do. Yeah, so for example, if we have a 4 and a 5, and both of them are bigger, then like we can either insert them anywhere, and it goes like up, some value goes up to 4 and then goes down. And then later on we have some value like goes up to 4 and like down. Even if it's like 3, 4, 3, that'd be plus 2, 3, 5, 3 is plus 4. That's total is 6. If we do 3, 4, 5, 3, then it's just 2 plus 2. Because a 4 is essentially... Oh yeah, but the 4 just gets overridden. Because we don't have to consider those blocks of values. Only consider the smallest min and the largest max, basically. And how we can fit these where we fit this value in. Okay, so the worst case is essentially just like if the array doesn't contain a 1, and if it doesn't contain a number bigger, that number at least as big as x. Okay. Yeah, because then we can like figure out where we want to put these values. I think we just do like some casework then. I'm going to like calculate prefix and suffixes probably. Or like just like DP in general, maybe. I'm gonna try this. So t n array, or t, I guess we also have a value of x. First thing we need to do is find the minimum and max. Okay, long res is equal to 0 if 1 is equal to new long. It's like where it's like this element is like the 1 is located before this element. Yeah, okay. And cost of 1, well, cost, which is like the cost of the minimum, is only if the min is strictly greater than 1. And we only do this if the maximum is strictly less than x. Okay. So something that we could do is cost 1 at 0 is equal to absolute value of 1 minus array at 0. Or it's like the cost of this prefix. How much memory are we allowed? I mean, this is O of n, right? I don't think of the best way to implement this. Because we need prefix of 1 and n, but we also need prefix of like n and 1. I guess I could just do like min is equal to solve n x array, and then just do something like this. Would probably be like the cleanest way to implement this, because like reversing does like the same thing essentially. Okay, cool. And then we can just do public static long solve index in array. We do something like this, and then but we also need to find the min and max of this array. True. Okay, so we found the minimum and maximum. So we'll have to by doing this and just reversing the actual array, we only need to calculate min at like some prefix. We just assume min and max. Because like max and min reverse, we just assume the min goes before the max. Or like a 1 before goes before that. Yeah, that's fine. Okay. Okay. So cost 1 is equal to this, long prefix is equal to cost of 1 and I is equal to the absolute value of array at I minus 1 minus 1 plus the absolute value at 1 minus array at I. What is this like? This value. And then when we want to calculate this value, we're going to add on to prefix. We want to add on to prefix, and prefix adds on absolute value array at I minus array at I minus 1. Okay, I think that's basically it. And then we want to find suffix where it's like costed 2, or I guess costed. Oh, I need that costed 2. Well, I think cost of x is a better name for this. Okay. Is equal to the absolute value of array at I minus x plus absolute value at array at something like this plus suffix, and then the suffix adds an absolute value at this. this is like at or after, essentially. So long res is equal to. So we want to like choose like every like, I guess, starting point basically. This calculates like an actual value itself. But we want to find like among all these prefixes. Like we don't want to just like do suffix ends. So yeah, we want the minimum cost. So cost at x at I is equal to the min of itself, where it's like I or later. Yeah, it's like after I basically, and then we do min at cost at I at x, something like this. And so for each integer value, suffix at I is equal to the min of itself, and then add on 1 to the cost. The best result we can get is minimum of res as in itself, and then we get prefix at I, where like at or before this, suffix at I is like at or before this. So long prefix is equal to cost of 1 at 0. And then prefix is equal to the min of prefix, and then array at, no, cost of 1 at I. Yeah, there we go. And then, in that case, we can just do for and I equal to 0, I is less than I plus plus. We just find like where exactly they become adjacent, and because in terms of if we assume that 1x is always like an order that we maintain, then in this case, then we can just do 1x adjacent. And then do something along the lines of 1x okay, this is all long temp is equal to all plus absolute value of array 0 minus x plus x minus 1. Temp is equal to min of temp itself, and then we do all plus absolute value at array n minus 1 plus x minus 1. Res is equal to min of itself and temp. And this is like where we do like all of the in-between values basically. Where in other words, this is like right before this value over here. Where we do long check is equal to, I guess something along the lines of we do all, but we want to all minus absolute value of array at I minus array at I minus 1. And then we want to add in absolute value of array at I minus 1 minus 1 plus absolute value of array at I minus x. And we add an x minus 1 for the pair itself. And then temp is equal to min, temp, and check. Okay. 9, 15, 31. Nope. Okay, 9, 6. Why is it 6? Three and 8 is 6. But it's actually 15. Like, well, 8 is negligible, so it's really only just like finding out where the 1 becomes, where the 1 belongs. Although some of this is already. Oh yeah, this doesn't make any sense as to why that's happening. This should flip it properly, right? I think so. Yeah. Okay, let's do this. Okay, it already became 6 up here, so that's no good. Min is min. If a min is strictly greater than 1, yeah, if a max is strictly less than x, which it is not. I know why. Oh, okay, I know why. Wait, we don't have to like actually handle this because then it would just like work by itself, right? Because our claim that they're always guaranteed a spot where like it would just get evened out. Yeah, wait. We don't even need min then. Like it would just handle it completely by itself. Let's see if this helps or not. Still not right, but it's slightly better. Still gave 8, so what about everything in general? Like 9848, that's definitely not right. Okay, well these contains 1s, which is why that becomes kind of weird, potentially. 3, 8, and then 7, 2, so Oh, wait. I'm pretty. Oh, okay, I'm kind of dumb. Okay, I think I'm just kind of dumb. I did not. Okay, hold on. I'm just stupid. Oh my goodness. What do I want this to be like the cost of a whole thing? Because the whole thing where like this x is located here. Yeah, whole thing where x is located, where the x is located somewhere in the suffix. But like it's actually the cost of like, well not, but like up to its own suffix and before. Okay, I'm just kind of stupid. It's not a hard fix though. Cost up 1 is still defined the same way. I just need to change how I'm like calculating the suffix and prefix. Because the suffix, well, the min is itself, that's like fine. But if it's like, in other words, like either like this right before is like a divot, or like here's a divot, but you want to add in array at I minus array at I plus 1. There we go. I think that fixes that one. PP cost it like this. The res is equal to the cost of 1 is 0 plus res equals cost at 1 0 plus suffix at 0 min pp cost at 1 and I suffix I plus 1 is like the previous value. Min pp plus absolute value array at I minus array at I minus 1. And this. And then we do this. Let's see if this helps. Okay, got 15 for that. Yeah, I was just being kind of stupid. Since when am I not dumb though? Are we doing 1x adjacent correctly? So we calculate the cost of the whole thing, and then temp is all, and then we append essentially. This is us appending 1x up to here. All plus the absolute value of array 0 and then x, yeah, plus x minus 1. And then over here it's like the same thing, except we append like 1 and then x. Same thing. Check is equal to all, and then we subtract this difference because we take this difference and replace it with 1 and then x. We don't have to do x1 because like reversing the array will just handle it for us. Okay, let's see. Okay, we got D. Alright, moving on to E. Cool. Moving on to problem E. Let's see what to do. Is E easy? Some people have solved it quickly. Given a rooted tree of 2 to the n-1 vertices and whatnot, okay. Each vertex of a tree. given a rigid tree of this many vertices, each vertex of this tree is either 0 children or 2 children. All leaves have the same distance from the root, and for every non-leaf vertex, one of its child is the left and other the right. So that's a perfect binary tree. So if it's not a leaf, it has 2 children, and all the leaves are the same distance from the root. The vertices of a tree are numbered in the following order. If the root has index 1, a vertex index x, and left child 2x. Okay, so just like tree ordering. Every vertex of the tree letter written A and B. To find the character on the vertex x says this. If a vertex x is a leaf, then the pre-order is only itself. Otherwise, the pre-order is itself plus the left plus the right. You have to calculate the number of different strings that can be obtained as a pre-order string of a given tree. If you are allowed to perform the following operation any number of times before constructing the pre-order, choose any non-leaf vertex and swap its children. I see. Okay. Every character is either A or B, so that's probably important. I was like, oh, okay, it's like a perfect. I see. AAA is a 1 because AA is the only string we can obtain. Okay. And swap its children. So basically what this means is in any given step of a pre-order, we can either go left, right, or right, left. And among all of these possible choices, which one is like that? Okay. It's pre-order. So the root always goes first. The length of every pre-order tree is the same. So if 2 children are like different characters first, then like those are guaranteed to generate 2 different orderings. If they're the same character, however, then it depends on like their actual children. Okay. Is that right? Yeah, I think that's right. Or like that makes sense at least. I'm gonna go to the bathroom while I think about this. Pre-order. Pre-order, post-order, something order. There could be a lot of nodes though. Wait, how big is this? It's 2 to the power 18 is that's a little over 200,000. 2 seconds. We have a lot of memory though. Like we're allowed a lot of memory. Oh, might just because long that might be why. We use those as longs potentially. Okay. So for a given root, it's two smaller vertices are the same, or not the same, but dp. Like for each smaller subtree, these generate different strings if we swap them. It's essentially we want to count between any two subtrees the number of shared strings that could happen. Where it's just like for some traversal, how many of their strings are the same? How many of these strings are the same and how many of these strings are the same? And so if we do something along the lines of how many strings are here? Yeah, because then we could just multiply them. It's we have some choice. Or I guess we just need no number of distinct strings among within each subtree, and then that just tells us the answer. Distinct substrings within each tree. Or okay, well maybe we need within each subtree the number of the number of strings in general, maybe? Because if we can generate this I know, it's just a number of distinct strings, I think. And if these two characters are the same, what is the number distinct in here times the number distinct in here? The problem is that if they're the same character, then these between different subtrees could be different. Or we could generate the same string. So now the question is, what does that number equal to? So if we want to count the number of distinct subtrees for this root, if these are different, then it's just a number of distinct subtrees, number of distinct strings that we can get in here, multiply the number of distinct substrings we can get in here, and we can flip it. So it's it's the same thing, basically. That's very different, yeah. It's A, B, or BA. Those are two different ways. If they're the same, however. If they're okay, if they're a string, for example, for both A's, and assume they're not leaves, because they're leaves and it's a base case. We know how many distinct strings are among all of these nodes, and we want to find number of distinct strings in here. Because the idea is that we have this mystery character. So we have mystery character, and then we do A, and then some traversal, and then we do A, and then some traversal. And so the idea is that if you do A and then some traversal, and then it's like a number of distinct traversals in here and here. We need to subtract a number of traversals that are exactly the same within here and then here. So, what's one way we can do that? Okay, well, we only want to do this for nodes that are in the same layer. So if we do like, for any two nodes in some layer, the number of nodes that overlap. We only want to do this like every other node, I think. So it's like at the very bottom layer, I mean, it could still be a lot though. But it's more like the number of strings that match in here and here. It depends on whether these, it depends on the contents in here then. Where it's like if we have some distinct substring in here, it's a little tricky though. Maybe there's a better way to think about this. In particular, operation swaps the whole subtrees of, okay, it swaps the whole subtrees of two children, not just the characters. So my understanding was correct of that. It also seems like Rainbow is about to get F. But yeah. I feel like, I mean, they had a lot of test cases. I feel like D wouldn't FST or get hacked. I also hope it doesn't. Yeah. Okay. Let's see. Maybe we might want to use the fact that A's and B's, that the string consists only of A's and B's. Because this solution doesn't really use that fact. It is only possible for these two substrings to ever be the same if the sum of A is equal to sum of B. If the sums in here, like what I mean by this is that I think we can think of it like this. If the sum of A and B is not the same as this, and like these two strings are never going to be the same. If these sums are the same, if the sums are the same, then it's possible that, well, okay, so let's say we have like some strings, like we have A, B, C, D, E, F, G, and it connects like this. One possible traversal is this is like the standard traversal. Can also do A, B, E, D, and then you can do E, D, or C, G, F, or we can do A, B, D, E, C, F, G. two choices in here. And then we can also like flip like the actual like C and B. There's 8. So okay. So maybe, okay, for each node, we want to keep track of the counts of A and B, or like the count. And I think like because it's A and B, we won't have to count one and like do the other, so that saves us some time in calculation. And then they only really match if their sums are equal, and if their sums aren't equal, it kind of had to be equal throughout everything. Which, yeah, it has to be equal throughout everything, and then in that case, let's just okay, I think I'm gonna do you do some sort of DP. Where did we? I guess we wanted to start at because the root is equal to 1. You can be in here if you want. Oh, never mind. Wait, where did... Oh, wait, you're working. Is there like a isomorphic hash we could use? Like some sort of hashing maybe? do hash at v plus equal to h1 times the power of size over 2. Well, it's actually mod I have to be careful with modding in here. Hash at v plus equal to h2, hash at v and hash at v. Okay, so I've calculated all the hashes. So now I do dp long dp equal to new long left at n, and at the very end we print dp as 0 or into v is equal to I meant 1. This should be 1, yeah, dp 1. So basically what we want to do is if child is equal to, so if child is less than or equal to, okay, well the base case is just dp at v is equal to 1 because there's only one way to do it. Otherwise it's dp at v is equal to dp at child times dp at child plus 1 mod if hash 1 at child is not equal to hash 1 at child plus 1, or if these hashes do not match, in other words they're not isomorphic, then this 16 1 this is 2 here we have 2, here we have 1. That's case 16. Are you kidding me? Wrong answer 28. Oh my god. Why? Why you gotta do this to me? What the fuck? Oh my god. That's really annoying. Do I need to do more hashes? I never used count to come to think of it. Or the count at child is not equal to the count at child plus 1. I guess I could use that as like another like layer of checking. But oh my goodness, bro. Like really? Is it like, I don't know if it's like because of hashing or if it's like they just use small test cases. Okay, well it's like B and then A, or A and then B. Well, obviously they have to have the same like node value in here. Because when I generated these hashes, they're isomorphic, so I've always put A before B. B and B are just whatever. Yeah, but I always swap them if this is a thing. Power size over 2. base 43. Maybe base 107 and base is 107 prime. Yes, is is 143 prime. No, is 141 prime. If 141 is prime, I'll use it. I think it's prime. Oh, never mind. 139 is 139 prime. Yes. Okay, I'll use 139. I'll use calc n array. Is this prime? Okay. N array something. This changed it to an 8. Use base. I don't know. Is 113 prime? Yes. Okay. For hash 3 at child is not equal to hash 3 at child plus 1. Okay, 1, 2, 2, 1, 16. Okay, so now I'm using if hash 1 at child is not equal to this, or so if any one of these hashes don't count, or if their like counts aren't the same. Am I using the right mod? Yes. Alright, let's see if this helps or not. Okay, what? Excuse me, what? Wrong user test case 28? Is that common? No, I guess it is. What could it be, though? Do two trees have to be isomorphic for them to generate the same preorder? Yeah, they do, because it's like two like preorder could potentially be the same only if like these two could potentially be the same, and like that's essentially a definition of isomorphism. Man, what? That's so troll though. Child at layer. Because two strings can potentially be the same in here. Because what happens is if these are not isomorphic, then there's gonna be like some section that will never be like the same, basically. Yeah, that section will never be the same, the whole string will never be the same. Oh man, what could I do? What could I be doing wrong though? Like that's so weird. This case 28. Maybe just like, is there a way you can do this without hashing? If there's a way we can do this without hashing, then that might help. I don't really see an easy way to do this without hashing though, because we want to compare any. Because in order to compare whether these two trees are isomorphic or not, we would theoretically need to know whether these below trees would be isomorphic or not. Wow, that is so annoying. I guess there isn't a way to do that easily. Oh, wait, what is his runtime? Is it really fast? Oh. Man, how many test cases? Man, how test case 28, bro? Like, why? Just why? DP child times child plus 1. If the hash, then the number possibility essentially doubles, because then it's like we could also do like it reversed. But if these are isomorphic, then it's just like it generates like the same string along here. If it's guaranteed that this string in here will never equal to this string in here. Could it equal to itself in store? Yeah, I guess it could. Let me make sure I'm doing the actual hashing properly. Okay, so everything is mod m in here, right? Yeah. We do hash of e is equal to, well, first we want to multiply it by the size of this subtree. Maybe instead of layer, we do size up here. Size is equal to size of child plus size of child plus 1. Size of people count plus increase it by 1 because we always use that. Then down over here, size just becomes we need to directly use a size array, because then it's just like we want to take this coefficient and multiply it by this much, and then yeah, so size increases by, well, it's just the size of the child. I don't think that would have been the reason why, though. Now this counts how many A's are in here. first node is always first node has to do this, and then in order for these to generate the same Euler Tor, the Euler Tor of this would have to equal this. If two things have B, then we can consider either hash in either order. Oh, that's why. Oh, I realized why. How do I handle this? I have a really easy way I could handle this. Because the idea is like we always want to have a fixed order. That's the whole purpose of like doing the BNA. We want to have a fixed order. So I wonder if we can just get away with doing min and max. Min of hash child plus 1. One, two, one. Oh, got it. Okay. Whew. We got it. Okay, that's my contest. I had a very stupid, or not, okay, it wasn't that obvious of a bug. The bug itself was not very obvious, but, yeah, the bug itself wasn't very obvious, but it was a very easy fix. But yeah. Okay, we did get E though. I want to just submit a version with 5 different hashes really quickly. I want to submit one with like a bunch of hashes just so I don't like check from 100 to 150. All prime numbers greater than. Okay. What's the prime numbers up to this? Okay, this is the website I wanted to look for. Let's do 100. 100, 101. Okay, let's do 167. But 167 is a base, and then long hash 5 is equal to count n array 233. And then if we do let's do this. And then we do for another random thing. Long hash 5 or hash 4 at child is not equal to hash 4 at child plus 1 or hash 5 at child is not equal to hash 5 at child plus 1. This is very excessive, but I don't really care. Because in educational rounds, they only check the Lex submission if your first one gets hacked, so it's actually worth doing this. Two AAAs, or to submit this really quickly. Yeah, same thing. It's basically just the same thing. Okay, but it's very unlikely that will FST. So, yeah, I think we're good. Yeah, and I don't think I'm ever getting F. I know how to solve it if n was smaller. It's a really standard problem, but aside from that, yeah. Alright, I don't think I'm gonna get F since it's kind of hard. I feel like it's like some sort of FFT or something like that. Actually, let me look at it just in case. K is 11. Okay, K is up to 11, X is up to 11. Calculate number of permutation size n with exactly K inversions. With exactly K inversions and exactly X indices. Exactly K inversions and exactly X indices such that this. Oh wait, it's really, wait, n can be really big, but X has to be really small. Wait, that's kind of interesting then. Maybe this isn't as hard as I thought it was. But I mean, either way, I don't think I'm going to get this in I don't think I'm getting this in the time that I have. So it's okay. Yeah, that's my contest. See ya.